time to do some experiments. Hold on a bit. I'm trying to, there we go. Okay, I had to figure something out. All right, so what are we doing today? We're going to test some waters. I'll wait till a few people get in here a little bit. Hope everyone's doing great today. The waters we're going to test are, what's this, smart water stuff, pH 9.5. And then we can compare that to this smart water, which, what does this say? Vapor distilled water and electrolytes for taste. It's purely pH balanced. I don't know. Might be fun to check these out, compare them, contrast them. And then we've got all these separate waters that I'm going to be testing here. We're going to test some Aquafina, some Dasani, some Evian water, some essential water, some of this Icelandic stuff. I don't know. We'll just see what everything looks like, shall we? So let's show you what the experiment's going to look like. And if you folks got questions about anything, or you want to, I don't know, if you got suggestions for experiments, we might do some of that too, okay? So, somebody let me know in the chat which one of these waters you want to test first. Anybody? Let's start with, I don't know, I'm going to go with Dasani. How's that? We'll start with Dasani water. Let's look at this here. What's it say? They say it's purified water, but it's enhanced with minerals for taste. Ron, what we're going to test for is pH, and we'll be able to do a couple experiments to sort of tell. You'll notice the different additives that are in here. So this one says it's got purified water, so they purify the water, and then they add back some magnesium sulfate. That's going to be a little bit basic. They also add some potassium chloride, which are minerals that are added back for taste. We'll be able to kind of see how many minerals are in this. I suppose as our control, we should test Aquafina first. The reason why we ought to test Aquafina first is because Aquafina is purified by reverse osmosis. You can see it says pure water, perfect taste. So this is purified by reverse osmosis. And then they don't add any, they add 0 additives back. So they do sell this as pure water. And, you know, perfectly pure water is very difficult to make. But this is probably as close to pure as you're going to easily get. So I'm going to put this little cup right here. And we're going to open up our bottle of Aquafina. And we're going to pour some of this water in here. It's going to taste like paint. Like matte paint, huh? Yeah, you know, what's interesting is a lot of people do not like the taste of pure water. It has kind of a sharp taste. I've noticed that when I taste pure water. It's got this sharp taste that I don't necessarily like. All right, and now what I'm going to do is I'm going to add some universal pH indicator. You'll notice that this stuff is green in color. And that green color tells us that the universal indicator is indeed neutral. I'm going to add a squirt. And look at that. Our Aquafina has an orangish color. That's a pretty low pH, man. That's quite low. That's like a pH of 4 or so. That's a little lower than I would expect. It's probably because I added quite a bit of the indicator. So I'm guessing like that yellow color is a bit deeper than I'm used to seeing, probably because I added too much of the indicator. But nevertheless, our pH is like a 4 or a 5. So it's a very, very low pH. And while it's purified water, you might be wondering, well, why isn't pH 7 neutral? That's because any water that's exposed to the atmosphere, like this is, right? Before bottling, this water is exposed to the atmosphere. Any water that's exposed to the atmosphere is going to have some carbon dioxide dissolved in it. And when carbon dioxide dissolves in water, the water gets acidic. So that's it. So that's why we're seeing the low pH in the Aquafina water. Now what I'm going to do, and we're going to do this test with all of the waters today, I'm going to add a drop of hydrochloric acid. It's 20% hydrochloric acid. This is the same acid that's found in your stomach. It's just that this stuff is like hundreds of times more concentrated than what's found in your stomach. And what we're doing is we're going to see how much of this acid it takes to acidify the mixture completely. So we're going to get down to a pH of 3. It's going to turn red. So I'm going to add just 1 drop. You'll watch me put it in. Boop, there it goes. We'll give it a swirl. Give it a little swirl. And we see a color change. I don't know if that's red yet. What do you think? What do you think? Is that red yet? Is that more pH 4 or pH 3? Let me know in the comments what you think. Neva is saying 3. Stan Lee is saying 4. Almighty says red, so it's 2 to 3. So it looks like most folks are saying it's pH 3. Okay, so if that's what you're seeing, that's a pH 3. I'm going to mark this particular bottle of water with 1 right here at the top because it just took 1 drop to acidify it. Just took 1 drop to acidify it. So I'm just going to put this 1 right here so we can keep track of it. And that's our control. And the reason why I'm calling this our control experiment is because this bottle of water is purified through reverse osmosis, and it has. The next thing we're going to do is we're going to test Dasani. Dasani water is also purified, but additives are added back. And that's going to shift things a little bit. Let's see. I mean, at least that's what I'm guessing. That's what the chemistry should do, but, you know, I can talk about the chemistry all day, but the real proof's in the pudding, right? Doing the experiment. So I'm going to go ahead and open this bottle of Dasani water, and we're going to pour it into our test container. We're going to try to use the same amount every time. About right there. I know it's not perfect, but it's going to be close. So this is the test of Dasani. I'm going to go ahead and add. This time I'm going to add just a little less universal indicator. Universal indicator, you'll notice it's green in color, so it's neutral. I add it to the mixture, and this time, hey, look at that. It starts out yellow. It starts out yellow in color, so the pH is a little bit higher. It's still kind of acidic, right? Slightly acidic. That's probably from the carbon dioxide that's dissolved in the water. I've not tested Dasani before, so this is all new to me. And we're going to add hydrochloric acid until it's acidified, completely acidified at pH 3 or lower. So we need to see a red color here. The additives should make it a little tougher to acidify the mixture. Here we go. Let's see. I'm going to add 1 drop. Boop, and it goes. Let's give that baby a swirl. Oh, look at that. I think it's red all the way. I think it's red already. I am wrong. My hypothesis is wrong. I did not think it would just take 1 drop because of the additives. What do they add to it? So I'm just going to put a 1 here because it only took 1 drop to acidify it. That's the same as our control. So in this case, the additives that they add back don't do anything to protect the water from being acidified when they add the hydrochloric acid. The question is, what do they add? If you look on the container here, you can see they add magnesium sulfate and they add potassium chloride. Sorry, it's a little tough to see. Magnesium sulfate and potassium chloride. So those are the 2 minerals that are added to Dasani water to give a little bit of taste. And this did the same as control. It just took 1 drop to acidify it. And the difference was this started at like a pH of 6, where the Aquafina started a pH a little lower. All right, let's try our next type of water. We can either try, let's see, we can do Ice Mountain. We can do Evian. We can do Essentia. We also have Icelandic. And I have these 2 different brands of canned smart water. We have regular smart water in a can. And we have smart water 9.5 pH in a can. Which one y'all want to test next? Ice Mountain Almighty. So the first person to comment gets the test. That's what we're going to do. We're now going to test Ice Mountain. Let's see this one. What does this one say? 100% natural spring water. So they don't tell you what's in here, but it is the case that when water flows through the ground as it would in spring water, it's going to pick up some minerals. So let's see if those minerals will affect the pH. In it goes. This is the Ice Mountain water. All right, let me move this over here so we can check it out. We're going to go ahead and add a squirt of our universal indicator, which is going to start looking green. It's going to start looking green. So it's neutral. In it goes. Hey, look at that one. Look at that one. This one is starting out a green color. So the minerals from the groundwater, the minerals, I should say, from the ground that dissolved in the water, in this case, they make it so that the pH is neutral. So the minerals neutralize the carbon dioxide that naturally gets into the water. That was different, right? That was the Aquafina started out like oranges, so that would start out pH 5. The Dasani started out pH 6. Now we're going to check out what's happening with the ice mountain water when I acidify it with the hydrochloric acid. Again, the same acid is found in your stomach. It's just that this stuff is a lot more concentrated. And we're going to add drops until we get to that red color. Okay, so let's go. We're going to add our first drop. In it goes. Boop. In goes the drop. Is that going to acidify it? No, it does not. It just lowers the pH a little bit. Like we're somewhere between 6 and 7 right now, yeah? It's like an orange, excuse me, a yellow-green. So one drop, wow, that only put us down to like a pH 6.5 maybe. Here we'll do our second drop. Here goes the second drop. Give it a swirl. Oh man, this is going to take a while. That got us maybe to pH 6, yeah? All right. I'm going to move this over so we can see. Ah, curses. Let's try that again. Come on, baby. All right, here we go. By the way, down there at the bottom, I spilled some stuff on it. That should look violet, but that doesn't matter for what we're doing. In your opinion, out of the 3 so far, which one would be most beneficial to your body? Ron, in my opinion, all 3 are perfectly fine to drink. The water's just to hydrate you, and there's plenty of water in there, and the amount of minerals they add is really just because we can tell a slight difference in taste. That's the third drop, man. These minerals are still neutralizing the acid. Here's the fourth drop. I don't think that's red yet. Here's the fifth drop. I think we're there, yeah? There we go. That took 5 drops. So in this case, we can tell that the ice mountain probably has more minerals than the Dasani because it took more acid to neutralize them. Good morning there, Madam Juror. Okay, well, I'm going to write a 5 on this. I'm going to write a 5 on this because it took 5 drops to neutralize. Yeah? So this one started out at a pH of 6, and it took 5 drops to neutralize. This one started out at pH 6, but it only took, sorry, I said neutralize. This took 1 drop to totally acidify. And then this one started out like pH 4 or 5 and took 1 drop to acidify. The question, Professor, isn't it true that the pH wouldn't matter as much in the end? It will equalize to the pH that is in your stomach, which is 2 or something. So, Imada, it is correct that the amount of base that they stick in these waters is minuscule compared to the amount that's found in your stomach. And so as soon as this stuff hits your stomach, the minerals that are in there are going to be completely neutralized by your stomach acid. It's going to have a minuscule effect at best on the pH of your body. So here's some extra waters that we're going to test. Evian, Smart Water in a can, and this Smart Water in a can that supposedly has a lower pH. Which one do you guys want to test? You people, I should say. We've got all the, I also have this Icelandic stuff. It tells you right there on the bottle. It says pH 8.4, so we can kind of test that. This says pH 9.5 plus. This one says pH 9.5 plus. I think the Evian on the bottle also says it's pH like 7.2. It says it right there, pH 7.2. Anybody? Oh, that's cool, Yamada. Thank you. So I have a former student in the chat. It's great to hear. Had you for Chem 1020. That was a lot of fun, man. That was a great class. That was a really great class. One of the first I taught at that particular university. Smart water can. You got it, Almighty. We're going to do the smart water can. Let's do both these at the same time so we can kind of like compare and contrast. They're both sort of smart waters. This one is advertised as having a pH 9.5. This one is advertised as having, it doesn't say. It does not say what the pH is, so we're going to discover that together, okay? So I'm going to just put these off to the side like this. We're going to get 2 cups. Let's get the cups for our test. Here's cup number 1, cup number 2. I'm going to have to back the camera up just a bit so we can see everything. All right, let me put these here. Okay, we are ready to roll. All right, in goes our Smart Water pH 9.5. Oh, it just sounds delicious. I am a little bit thirsty. I went biking today. Okay, so this is the pH 9.5 water. All right. And here is the one where the pH is not advertised. Now you got to see me open it on camera so you know I'm not fooling you. Got a sophisticated audience here. I don't want to act like I'm trying to fool you. Here we go. So we got the water from a can. All right. In goes universal indicator. So this one should be violet. And it is. Yep, it's violet. So that means its pH is roughly 10. This one over here is not violet. That matches expectations, right? This one's going to be violet in color. Let me stir this one over here with a different stir. This one's more closer to pH, I don't know, like pH 7. Yeah, that's cool, man. It's like the Joker colors. I'm loving it. I'm loving it. We got the Joker colors going on. Let's check out those pH levels. So over here on the left, we got a pH of 10. I know that's a little screwy down there. This whole thing's supposed to be violet. And sure enough, this is violet. And that tracks, right? This says pH 9.5 plus right there. That tracks. That's not false advertising. Over here on this side, we've got this can of Smart Water. And this one's got a lower pH because it's going to have different additives. So yeah, different waters have different additives, indeed. Now what we do is we are going to count how many drops of this acid it takes to neutralize, actually acidify, right? Acidify the content. So here, how you doing there, Tennessee? So we're going to add the hydrochloric acid, which is stomach acid. It's just this is about 100 times more concentrated. We're going to add it until this turns completely acidified at pH 3. Okay, so let's count our drops. First drop over here, 1. Come on, man, look at that. Come on, man. Ha, it only took 1 drop. It took 1 drop, and this mixture was acidified. Now, why might that be? I mean, come on, it's a stinking high pH. Well, the minerals that they add, there are some of them that are strong bases. And I shouldn't say strong bases. There's stronger bases and some are weaker. And if you can add minerals that are stronger bases, you can get the pH real high. Now, the fact that it only took 1 drop, I'm going to write it right here, it only took 1 drop to completely acidify this mixture tells us that even though they added some minerals that were a very good base or a pretty strong base, they didn't add very much of it. So it didn't take very much acid to acidify it. Hey, someone's got a son. Tennessee Black had a son born May 3rd. Congratulations. That's really cool. Okay, now we're going to test, excuse me, this one over here, which starts at pH 7. We're going to test how many drops it takes to acidify. Here we go. In goes the first drop. Boop, and it goes. Let's give it a swirl. And that also was acidified with a single drop. Man, it's kind of boring tonight, man. Everything's like acidifying in a low number of drops. So let's pull these out of the way. Right now, our champion, the one that took the most drops to acidify, is little old Ice Mountain. Everything else took only 1 drop to acidify. Ice Mountain water took 5 drops to acidify. The weaker the base, the stronger the conjugate acid. You got it, Jay Glover. A chemist has entered the chat. All right, we got 3 more waters to test. We got Icelandic, we got Evian, and we got Essentia. And I think I got some Fiji water over here we could test too if we got the time. And I also bought some of this stuff. What is this? Waiakea? Waiakea? I don't know. What kind of water you want to test next, folks? What kind of water are we doing next? I'm just waiting. I'm waiting to hear from you, giving you a chance. Please test the Fiji. Lynn Davison wants to see the Fiji, and you got it. That's what we're doing next. That's the one I heard first, so that's the one we're going with. So we're going to put the Fiji front and center. Let's see if Fiji can beat the champion. The champion, this one, Ice Mountain, took 5 drops to completely acidify. We're going to put the champion right back there at 5 drops. Ice Mountain is buffer. We can find out. We'll do that one next, okay? Where's my Ice Mountain? Oh, Ice Mountain. Sorry, we already did it. Yeah, that's right. Ice Mountain is buffered fairly well. That's correct. So here we go. We're going to test the Fiji water. We're going to see if it's got a better buffer in it. In goes the Fiji. Whoop. Okay, here's my Fiji water. So Tennessee is saying 2 drops. Put the champ over there in the back. Let's add a squirt of our universal indicator. Down here, you can see the different colors that the universal indicator will display. Put it over there at the different pH values. In goes our universal indicator, which you'll notice starts out green, which is neutral. In it goes. It remains green. Actually, it turned a little bluish green. I don't know if you noticed that. So its pH is probably a little bit higher than the 7. Let's see if there's any information on the back of the bottle that we can check. pH, look at that. It's really hard to see, but it says 7.2. If you check your bottle of Fiji, you'll see a 7.2 for the pH, and that tracks with what we've measured here. Okay, that definitely tracks. That's consistent with our measurements. Makes me feel good. They're not lying to us. Now we're going to start to add hydrochloric acid. How many drops going to take to neutralize this stuff? I don't want to say neutralize. I keep saying that. To acidify, completely acidify the minerals that are in there. We're going all the way. How many drops to get us to red color pH 3? Here we go. In goes our first drop. Boop, 1 drop. Give that a swirl. And we're at yellow. We are at pH 6 with 1 drop. Let me get all that green stuff in there. Okay, here we go. Next drop. Second drop. In it goes. Oh, not yet. We're still at yellow, man. All right, third drop. We going to beat the champ or not? In goes the third drop. That took 3 drops, man. That is only 3 drops. Ice Mountain is still your champion. Ice Mountain still your champion. Fiji took 3 drops to acidify. We're going to write the 3 right there on the container. But that's your second place right now for the water that's got the most minerals in it that needed to be acidified by the hydrochloric acid. All right. Next water up. Next water we're going to test. I don't know. You were close, Tennessee. We've got Icelandic. We've got Evian. Which one you want to try? Lynn Davison. All this means is we're testing the original pH of the water, and then we're getting a somewhat of a crude measurement of the amount of minerals in each water by seeing how much acid is required to turn the mixture very acidic. Lissa, Icelandic, you've got it. We're going to test Icelandic next. I'm going to pop a new little bottle up here. All right. And we're going to add some Icelandic water. Hey, be sure to give a like if you like this little experiment. It helps out every little bit. You know, you hit that like button and it helps with the cost of materials for sure. In goes the Icelandic. And all right, let's give it a 3 to 4 drops. Guessing Tennessee. Let's see, buddy. Let's see. In goes the universal indicator. That also. Oh, look at that. It's got like an aqua color, and that tracks. Come on, baby. It says right there pH 8.4, and look at this. Look at how well that matches pH 8, huh? Isn't that great? They're not lying to us. That's indeed the pH that's in this bottle. And generally speaking, I find the products to match fairly well what's said on the bottle. Now we are now going to test lots of volcanic materials. Let's see, Jay Glover. We're now going to add hydrochloric acid, same acids found in your stomach. It's just this stuff's a lot more concentrated. We're going to start adding drops of this to see how many it takes to get us to be acidified at pH 3. Our champion right now is Ice Mountain, which took 5, which tells us this one's got a lot of minerals in it, a lot of basic minerals. Fiji was number 2 with 3 drops. Let's see what place this one's going to end up. Icelandic, here we go. First drop, and it goes. Let's give that baby a swirl. 1 drop, man. There's like nothing in there. There's like nothing in there. Come on, man. So yeah, its pH was a little bit high, but it's hard to draw a 1 on there. So we're just going to stick it on here like this. 1 drop. Sad. Now look, man, I'm just having fun. It doesn't really matter. These waters are all going to hydrate you. They all got water in it. That's what hydrates you. It's the water that hydrates you. The minerals really only matter for taste. They might provide minuscule nutritional value because there's just so little. You can just see it's only taken a few drops of this acid to, to acidify the tiny amount of minerals that are added. Okay, here we go. I know, right? Up next on the docket, Evian, baby. Evian's next up on the docket. Let's see if it can unseat our champion of Ice Mountain. Here we go. We'll do that next. I agree. Waiakea or whatever the heck it is. I don't know how to say it either. Okay, I think we can zoom in a little bit better so we get a little better view of everything. Yeah, that's good. We get nice color. So you're saying 3 drops? Your body's made of 102 minerals? I'd like to see the evidence for that claim. 102 minerals. I forget how mineral is defined. Here we go. I've added the Evian water. Oh, it almost spilled. I almost made a mess. Fortunately, I caught it. Here we go. 1 drop, says Jay Glover. All right, let's find out. Here's the different colors you might see. A little tough to see. There's the different colors we might see at the different pH values. I'll stick them right there. There we go. Let's stick in 102 elements. Yeah, I don't think there's quite that many elements in our body. Okay, here we go. There's our green universal indicator. In it goes. And it looks like the Evian water is pH 7, right? That's a nice green color. That tracks with what it says on the bottle. It says it right there on the bottle. You can see pH balance 7.2. They're not lying to us. Now we're going to figure out how much acid it takes to completely acidify. Yeah, I am, Yuri. To acidify our Evian water down to pH 3. Here we go. Let's figure it out. In goes the first drop. 1 drop. Let's give that a swirl. We are at, man, that's still like 6.5. Let's do 2 drops. There's a second drop. Oh, man, we got some buffering going on. Here's the third drop. There's the third drop. Oh, man, this is good. That's 3 drops, man, and we're still at yellow. Here goes the fourth drop. Drop number 4. It's still yellow. Could we have a tie? There we go. Drop number 5. Will it tie the champ? There's the 5th drop. Man, that is like just barely yellow-orange. 6th drop. In goes the 6th drop. And we got a new champ, folks. I think that's red. What do you all think? Yep, I think that's red finally. It took 6 drops, and we've got a new champion. It took Evian a total of 6 drops. Ron, what buffering means is a buffer is something that resists changes to pH. And you can see it took quite a bit of acid for me to add to change the pH from the original down to pH 3. This took 6 drops, man. This is our new champion. It is unseated Ice Mountain, which took 5. This one took 6 drops of acid to make it turn that red, that acidic red color. That I should say that very acidic red color. All right. I think we got one more, man. This is the last one to test. I've never tested this one before. I'm interested to see what happens. Very interested to see what happens. We're going to test this Waiakea. Look at this stuff, man. Hey, thanks, Yuri. Yuri just subbed. I appreciate that. What is this stuff, man? I don't know. Waiakea. I just saw it today at the store when I was prepping for the live. Thought it might be fun to test something I've never tested before. What's it say? World finest. World's first ocean plast bottle, whatever that means. Hawaiian volcanic water, deep well water, electrolytes. Man, they put so much stuff on here to try to sell it to you. But look at this. They say naturally alkaline. What that means, okay, they say naturally alkaline. All that's saying is we should expect a pH that's above 7. So we should expect somewhere in the 8, 9, or 10 region. The 10 should look violet when we test this water. That's what that means. I mean, it might be, like a bluish green. What else does it say on here? Oh, look at that. Naturally alkaline, 7.6 to 8.2. So what that means is we're probably going to see like a slightly deeper green color would be my guess. Maybe aqua. So let's give this baby a shot. Please zoom out a little. You're welcome. Sorry about that. All right. That's as far as we're going to zoom out right here. Okay. In goes the Waiakea water. Man, I want to take a sip of this, but I can't because I'm in the lab. Can't sip because I'm in the lab. Thank you there, Random News. Here we go. We're going to test Waiakea. Waiakea water, baby. All right. We'll do this so we can kind of keep track of both. So what are the takeaways from this experiment? Should we drink the more buffered waters? Computer lady, it depends what you're looking for. The more buffered waters are going to tend to have a slightly better taste, but all of these are going to hydrate you just fine because guess what hydrates you? Water hydrates you. And all of these contain obviously much more water than anything else. Water is life. Here we go. So and what's nice about bottled waters is at least you know that they're not going to contain stuff that might be in groundwater, which is say lead or other minerals that may not be so good for you. So anyway, I got a little bit uh, yeah, minerals have benefits for the body, Random News, but the amount of minerals that are in here are so minuscule. They're so tiny as to not really have any effect. You'd be much better just, sprinkle a little salt on your food or just eating food in general. Like food contains minerals, obviously it does. Okay, here we go. All right. Then we should talk about this. I'm not 100% sure that the body is made of 100% minerals because, for example, vitamin C, for example, is in your body, and vitamin C is not considered to be a mineral. That's a vitamin. So mineral has a very specific definition. All right. Anyway, we're going to go ahead and see how many drops of the acid it takes to neutralize our Waiakea water. Here we go, baby. In goes the first drop. And we'll give this a swirl. Man, look at that. Look at that, man. There's like barely anything in there. Barely. I can do that. Jay Glover, we can make some seltzer, and I got some sodium hydroxide. I think that's what it's called there, Kyle. Look here. Look at the name of this stuff. Waiakea. It's from Hawaii, so I think every vowel needs to have sort of um, its own syllable, right? Yeah, it just took one drop, man. So that means there's probably not a whole lot of minerals in this thing. Just took one tiny drop to neutralize this stuff, so we're out of the way. Man, that was fun. That's everything I tested. Everything I tested. But I did get an example of somebody who wanted me to do another experiment, which was, hey, let's take some seltzer water and let's do the opposite. So let me show you. Kind of. We'll give you the background of the experiment. The person in the comment didn't mention everything that's involved in this experiment because it is involved, and it's tough to write everything in the comments. So here's what we're going to do. I am going to take. What am I going to do? I'm going to take. Hold on. It's going to take me a second to think this through. I gotta find a container to put my extra water in. Oh, poop. Where can I put this? Forgive me a second. I gotta find. Here we are. I can put it in here. All right. Give me just 1 second. We're gonna make some seltzer water. You guys are gonna love this experiment. Okay. So I got my bottle here, my soda stream bottle. And we are going to take my soda stream bottle and I'm going to add to it some Aquafina water. I'm going to add Aquafina because this stuff is purified water. So this is as pure water. It's not as pure as you can get, but this stuff is really pure. All right. So we're going to open the Aquafina and we're going to pour this into our bottle here. So we know we're getting quite pure water that's in here. Is that all the way to the fill line? I can't tell. Oh, it's past the fill line. Let me get just a little bit out. Pour it back in here. A little bit more. All right, we're close. Okay, now what I'm going to do is I'm going to add my universal indicator. Remember, this water is pure. Very pure. Okay, so let's watch what happens when I stick in the universal indicator. And it goes. Remember, the universal indicator starts out pH 7. In the water, though, in the very pure water, hey, look at that. It's got like a orangish color. Let's add a little more so we can see that color a little bit better. Add just a little bit more color. There's a little more water, so we need a little more color. That's like an orange color. What gives, man? Why is it like pH 5 or so? Because that's pure water. Pure water should be pH 7. Well, the reason why is because any water that has carbon dioxide dissolved into it will have an acidic pH. And any water that's exposed to the air will have carbon dioxide from the air dissolve into it. So any water is exposed to the air, which Aquafina is, all these waters are exposed to the air prior to bottling, then that carbon dioxide in the water is going to make it slightly acidic. Now what we're going to do is we're going to make this seltzer water. We're going to do that by putting it in the soda stream machine. So you can see my claim about carbon dioxide going into water and that making the water acidic. So I'm going to just actually put this, if I can get it in there right, we're going to put this bottle in this machine. All right, you can see it. So I got my soda stream machine all ready to roll. I'm going to try to put my light a little bit here so you can kind of see what's going on a little bit better. Okay, I think that's going to help. Yeah, you can see that. Okay, now look at this. We're at pH 5. I'm now going to pump carbon dioxide into here just by pushing on the top of the machine, okay? So we're going to check out what happens. There we go. 1, 2, 3, pump. What do we see there? I don't know about you, but I saw a color shift to red. Of course we saw a color shift to red because I just poured carbon dioxide, I should say pump carbon dioxide into here. And anytime you pump carbon dioxide into water, the water's going to get more acidic. Now, I pumped a bunch of carbon dioxide into here, which is why the water is so acidic. Look at that foam just settle out. Isn't that beautiful? And what's interesting, you can also see the foam itself is orange. It's more orange compared to the water. That's because there's more carbon dioxide in the water than there is the foam. Isn't that cool? All right, let's take this out and we're going to do some experiments with it. We can do the opposite in this case. So before, what we were doing is we added acid to water to make it acidic. In this case, the water is already acidic. So what we're going to do is we're going to add base to it to neutralize the acid that we made by pumping carbon dioxide in. All right, we're going to do this 2 different ways. Here, I think we'll just do it like this. Let me go ahead. Here's my control. I'm going to pour a little bit of this out. I'm going to pour a little bit of this out into this cup. And I'm going to seal the rest. All right, I'm going to seal the rest. This is my control. That's sealed. And so the carbon dioxide is going to stay in here. This other one, what I'm going to do is we're just going to start pouring it back and forth between 2 cups. So here we go. And as I do this, you'll notice it starts to fizz. Why is it fizzing? Because as I'm agitating this, the carbon dioxide is escaping. Yeah? You know this, right? You leave soda pop out, and the carbon dioxide escapes, and the water goes flat. Well, if carbon dioxide going into water makes the water more acidic, carbon dioxide coming out of water should make the water less acidic, and the pH should go up. Let's see what happens. We'll have to do this quite a few times. I don't know. I don't know if it's going to get enough out to change the color. That's what we're doing. We're doing an experiment to find out. I wonder how many times we're going to do it. Let's do it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. They still both look pretty red. Let me keep going here. I might have to do this too long. Here. I know how to do this. We should, oh no, that'd be cheating. Let me just keep doing this for a bit. It may take a little bit longer than I wanted to. Sorry, you're going to have to bear with me. I think it's getting a little more orange as I do this. Carbon dioxide's escaping. It should be getting more basic. The pH should be going up, and this should look a little less red and just a little bit more orange than the control. And I think I figured out a way that we can show that. Give me a second here. All right, there. That's looking a little more orange to me. Yes, indeed. And to show you this, I'm going to pour this directly out. And you should be able to compare the two. This is the fresher stuff. Come on, baby. You can totally see that. Yes, indeed. I see a difference. Yep, the one that was left undisturbed is more red. This has more carbon dioxide in it. The one that disturbed, it's got a slight orange peach color to it. And indeed, the pH went up. Now, let me show you. pH went up a little bit, right? We went from here to maybe here because I disturbed the carbon dioxide and made it escape. Now we can do, though, just like we did to the other tests, let's add just a little bit more of this water here. All right. And I'm going to start adding drops of base until we completely make this basic. We'll see how many drops it takes. So we're going to go from pH 3 all the way to violet, which is pH 10. Let's see how many drops of the base it takes. Here we go. I got my base right here, 20% sodium hydroxide. This is the chemical opposite of an acid. Let's see if we get this. Here's our first drop. Oh, I can see that violet color at the bottom. Do you see it? That tells us that this should maybe... Oh, that was cool, wasn't it? We got a little rainbow action going there. That's beautiful. So we're up to what? pH 6? Yes, indeed, we are up to pH 6. We went from 3 to 6 in a heartbeat. All right, let's do another one. There's our second drop to our soda water. You see that purple at the bottom? That's where the base sunk to, so the pH is very, very high there. But when we mix the two, neutralize each other. And man, there's a lot of acid in there, right? Neutralizing that base. Here's our third drop. In goes the third drop. You can see the base on the bottom, that beautiful violet color. And it's it. Oh man, there's a lot of acid in there. There's a lot of acid in there neutralizing it. What was it, the fourth drop? I can't remember. Here's drop number 4, I think. I can't remember. Tell me which drop I'm on, folks. Somebody tell me. I can't remember. Which one drop am I getting ready to add? Come on, somebody help me. All right, I'm getting ready to add 4. Thank you, Brittany. Thank you, Super. Thank you, Yuri. Thank you, Lynn. Thank you, Pamu. All right, here's drop number 4. Boom, and it goes. Oh, there we go. All right, next one. Drop number 5. Man, this is taking a lot. There's a lot of acid in there. A lot of carbon dioxide. I think we're finally neutral. Oh, no! It's not. Now, the reason why you saw that shift like that, is because the reaction between the base that I'm adding and carbon dioxide is slow. You can totally see it. You know, I add it, the base is there, and then slowly the carbon dioxide neutralizes it. Yeah, it's quite acidic. So you're saying, what is this? This is drop number 6 right there. Boom, in goes drop number 6. All right, give that baby a swirl. Drop number 6. Let's see if the carbon dioxide... We're kind of pH 8, but we're going to let that CO2 react with it a little slowly. No. Oh, here we go. Drop number 7. I think we're going to need more than 8. Drop number 7. Boom, in goes drop number 7. Drop number 7. It does look kind of green. I think we may be neutral. Drop number 7. There it is. Took 7 drops to get us to pH 8. Here's drop number 8. We're going to try to get this all the way to violet. Drop number 8. Getting close. Drop number 9. If you like these color changes, you'll like the experiment I'll do next. Drop number 9. Are we going to get to pH 10? Drop number 9. I think we're there. Is that violet? That's violet, baby. Come on now. It took us 9 drops, man. A lot of carbon dioxide, a lot of acid. Took a lot of drops of base to get us there. That was pretty close. Let's do one more experiment. You guys are going to love this, I promise. This one's fun. This will be our last experiment for the night. And then after experiments, I usually flip the camera around. I talk to people if people want to do that. If you don't want to do that, that's fine too. All right, let me get my, I got to get my next flask out. And do I have my... Uh-oh. Uh-oh. I got to go upstairs real quick. I got to get my magnetic stir bar. It's going to take me 30 seconds. Here we go. Be right back. All right, I'm back, everybody. Thanks for your patience. I got my magnetic stir bar. I got to get a good flask for us so we can set up the next experiment. Let's see, what am I going to use? I guess I could use that little guy right there. That'll work. That one will work. All right, let's put this flask up right there. I'm going to put in my stir bar. We're going to get my stir bar spinning. Okay, now we're going to add some water. It doesn't really matter what type of water. Let's add the Waikiki water or Waiakea water. Sorry there, Ron. Sorry about that. Appreciate your patience. Here we go. We're going to add the Waiakea water. Okay, there's that. Now I'm going to add... What are we going to add? We're going to add universal indicator. Let me get the universal indicator added. See what the pH is. Nice little vortex going on, huh? Let's add that universal indicator. In it goes. And we got a nice green color. So the Waiakea water is fairly neutral. Fairly neutral. Now what I'm going to do is I'm going to add... I do too, man. They're really cool. I'm going to add... I'm going to try to get this just look a little prettier. Sorry I do that sometimes. It just want to look nice. There we go. I'm going to add some milk of magnesia. See, this stuff is kind of cool. It contains a solid base. The solid base it contains is called magnesium hydroxide. You can tell it's a solid in the following way. I mean, it's suspended in water. The solid is suspended in water. So that's why I can kind of draw it up with my, see this, with my dropper. So you can tell it's a solid because look at that. Look at that white stuff, man. Like you can't see through it. It's because there's a bunch of little tiny solid particles in there. All right. Now what I'm going to do is I'm going to squirt this stuff in, and some of that solid is going to end up dissolving into the water. Watch what happens to the pH when that happens. Remember, we started out like a green color. I'm going to add a little bit more because I want to get more of the solid dissolved. Oh, you can already tell it's like pH 8 now, yeah? You see how the pH is shifted? That's because a little bit of the solid has dissolved. Not all of it. I can tell not all of it has dissolved because look, it's got like this cloudy appearance. That cloudy appearance tells you that there's little tiny solid particles of magnesium hydroxide, which is a base, in the flask. We're up to like, man, we're like pH 8, right? Maybe pH 9 now, huh? It's kind of got a blue color. It takes a little while for the solid to dissolve. Not all of it will. We'll know the solid has dissolved if it gets transparent again. You see how it's not transparent? I can't see the vortex anymore. Yeah? I think that's kind of almost getting violet. We're getting there. Just give it just a little bit more time. Maybe I'll add just another squirt to speed it up just a bit. Just a bit. By the way, after this experiment, if you want to hang out and talk, I'm happy to do that. I'll hang out and I'll flip the camera around. You can see my ugly mug. You're going to be looking at an old man in his basement. That's fair warning. And I'll just talk to y'all. See how you're doing. We'll talk about the different stuff. You're right. We got a colloid in there. Colloidal suspension of a lot of different solids. Excuse me, not a lot of different ones. One solid. The solid is magnesium hydroxide. That is indeed a violet color. So we are all the way up here at pH 10. We have a solid in here with a little bit of dissolved magnesium hydroxide. Now check this out. You're going to love this. I'm now going to add hydrochloric acid to the mixture, okay? Here we go. I'm going to add let's go like 4 drops. Let's go like 5 drops. Ready? 1, 2, 3, 4, 5. The acid goes in. Of course, it turns red. But notice the solid hasn't dissolved. Because the solid hasn't dissolved, it's reacting with the hydrochloric acid. And look at that. It's neutralizing it. It's going very slowly. But you can see we started at a pH of 3, and we're already up to pH 7 now. And as that solid continues to react with the acid, you will continue to see the pH shift and rise. Isn't that beautiful? Absolutely beautiful. Let's add just a little bit more of the magnesium hydroxide to see if we can't just speed it up. Going back to violet just a little bit. All right, I'm just going to add a little bit more. Just speeds up the process. Give it a good squirt. That helps things out. Now we can see that shift back to that. We're like a pH 7 or 8 right now. We give just a little bit more time. That looks like pH 8. I agree, Yuri. It's absolutely beautiful. Now we can still tell that there's solid in there. That's because it's opaque. It's not transparent. So there's little tiny particles in there that the light bounces off of, so it's not going to be transparent. And now I'm going to add, once again, I'm going to add a bunch of acid. That acid is dissolved, and that's going to immediately drop the pH. Let's give it like a good squirt there. Boom, there you go. Look at that big squirt. That dropped the pH like crazy, but that solid that's in there is going to react with the acid, and back it goes through the rainbow as the solid reacts with the acid and pulls that pH back up. Let's go, Le Chatelier, baby! Glover, Jay Glover, the chemist, has entered the chat. Let's give it another shot here. Give it another shot of acid. And I'm going to keep doing this until this becomes transparent. When this becomes transparent, I know I've reacted away all of the magnesium hydroxide. That's just gorgeous. Give it another shot. It is still a bit murky, so there should be magnesium hydroxide in there, and we will know when we see the pH shift back. There it goes, baby. Come on now. We know there's some magnesium hydroxide left, but you can tell there's less solid in because I can see through the mixture a little bit better. It's still murky, so there's still a little bit solid in there. Thank you there, Paper Dragon. I'm going to give a big old squirt here, trying to get it to go all the way. See, I think I may have dissolved it all, but we're going to find out. It still looks a bit murky to me. Has it completely dissolved? I think it may have. I think we may be done, folks. Yeah, you can see, I think I've reacted away all of the magnesium hydroxide. You can totally see through the solution now, and this should not shift back to any other color. There you have it, folks. That was a lot of fun. Had a good time here tonight. I'm going to flip this camera around, and you and I are going to talk science, life, and whatever you want to talk about. Get a chance to see my ugly mug. Thanks for being here tonight if you're getting ready to take off. If not, we're going to hang out. We're going to talk and just see what's going on in different people's lives. I'm happy to answer any questions. Just talk. I do have a PhD in chemistry. I've had that since 2005. Got it from the University of Michigan. I know quite a bit about chemistry and science. I don't know everything, but I know some stuff. You got some questions, we'll be happy to answer those for you too. And I do like to do a little bit of cosplay if you notice the reference. Some of you will, some of you won't, and that's okay. How you doing there, Paper Dragon? Take the worst water you got and then add sodium to carbonate and then test it. That sounds like fun. What is tomorrow for you, Paper Dragon? I'm guessing it's your birthday. Is that right? That's right, Almighty. Hey, happy 15th there, Paper Dragon. Happy 15th. Happy 15th. Great to have you on board. Happy birthday. What else is happening out there, folks? Anything going on tonight? Tronco, were you here last week? We did pretty much the same thing we did last week, where we tested a whole bunch of different waters for pH and how much acid it took to acidify them. Thank you there, super best friends. I tell you what, man, my shorts are not doing so well lately. I think YouTube changed something in the algorithm, and it doesn't seem to my shorts don't seem to be doing as well. So be sure to like and share them. It helps out. Hey, thanks there, Ember. Sorry you didn't have a good experience. What was the title of my thesis? And still I do have it. Yes, the title of my thesis. Let's see if I can remember it. Holy cow. Well, I can tell you in 2 words the title of my thesis. Nobody cares. I think, okay, it was uh, redox chemistry of the calcium manganese cluster. Calcium manganese, that's right, calcium manganese cluster of photosystem 2 as probed by reducing agents. Something like that's pretty close to what it was. So long there, paper dragon. I think that's what it was. Something like that. The world needs candy. I see you out there. Yeah, that's. I wonder how close I am to the actual title. Redox chemistry of the redox chemistry of the calcium manganese cluster of photosystem 2 is probed by reducing agents. What does that mean in layman's terms, Brittany? What it means in layman's terms is, I'm guessing you know what photosynthesis is, right? That's the chemical reaction that plants use to make sugar, and as a part of that reaction, they give off oxygen. Well, that's good stuff for us, right? We need that O2. So there's an enzyme in plants that kicks off the first reaction of photosynthesis. See, photosynthesis is actually the sum of a whole bunch of different chemical reactions. And I just studied the very first one of those reactions. And in that reaction, water goes into the plant, and the plant, there's an enzyme in the plant called photosystem 2. That's the photosystem 2 part of it. Anyway, that the water goes into photosystem 2, and the plant does some chemistry, and the oxygen pops off. And there's a bunch of certain metal ions, they're manganese ions, that are involved in this process. There happens to be 4 of them. And I did some chemistry experiments to figure out what were the charges on those manganese ions that takes in the water and pops off the oxygen gas. And I figured out the charges by carefully adding chemicals. I counted the chemicals that I was adding to the manganese to try to figure out what the charges on those manganese ions were. Oh, that's awesome, man. Lynn knows law and plays guitar. That's awesome, man. I'd love to play guitar. The plant splits the atom. Kinda. It's more like the plant splits the water. If it split the atom, the plant would really be getting some energy. So the plant does chemical reactions. When you split an atom, you're doing nuclear reactions, which are thousands to millions of times more energetic than chemical reactions. Uh, Pamu, it was actually +3 and +4. So it was 2 manganese 4 ions and 2 manganese 3 ions is what we found. Oh man, you worked at Argonne Lab. I bet that is cool. I visited there once. I got to see the Feynman van there. So super best friends. What I do for a living is I am indeed a chemistry professor. I teach at a university in the Midwest and absolutely love it. I have a great time. We have a great time. Try to do an experiment in every class because come on, man, you got to do experiments if you're learning chemistry, right? I mean, it's subject can be dry if all you do. I mean, I didn't find it that way, but I'm a nerd, and I know most people aren't. Yeah, I love the stuff, man. I absolutely loved it. But I think it helps most people to get their teeth into chemistry by seeing the experiments and then relating what we're talking about to those experiments. Ron, absolutely. If you alter the pH of the water, that totally could. Most enzymes all over your body and plants and everywhere, they operate within a certain pH range that works best for them. And that pH range is going to be different for different enzymes within the plant. And what's beautiful is like the plant regulates this, just like your body does, right? Your body has different regions of pH within it. And if you screw up that pH balance, you're going to be in trouble. And people try to do things to alter that. Man, you can't alter that. Like it's like, okay, I mean, sure, you can alter it by like being completely unhealthy, but there's almost no way that you can alter the pH of your body, say by drinking alkaline water or something like that. Your body in most healthy individuals, even if they're like doing unhealthy stuff, is going to be tightly regulated. I mean, our bodies are fine-tuned machines, baby. Evolution has done a hell of a job of doing that over the years. So someone ended up teaching English, but considered cum for a couple heartbeats in college. Brittany, I was the opposite. I was chemistry and considered doing English for a bit. Thank you there, Super Best. Oh, that is cool, man. Super Best. When you add like, I think it's like those aluminum salts that change the color of the hydrangeas. Isn't that right? Yeah, there you go. Do the hydrangeas. Yeah, that's really cool, man. That's cool stuff. Very nice. Well, folks, we just crossed the hour mark, and that's about all I can handle. That's all the energy I got for you. I'm sorry, I'm an old man, but it's getting close to bedtime for me. Um, but thanks for hanging out with me tonight. We saw a bunch of color changes. We talked a little bit. We had a good time. Tested a little bit of water. It's good stuff. Really good stuff. So thanks for being here. Appreciate you watching. It's always been a dream of mine to do chemistry experiments for people. And so, in a way, you're making my dreams come true. So thanks for being here tonight. And hope to see you maybe next week. Hope to see you on my channel. I got a shorts video out right now that's doing pretty well. I think we hit well over 100,000 views on the shorts in just a little less than 2 days. You might want to go check that out. You can see me pouring some liquid oxygen over the poles of a strong magnet, and you can just hear it crackling as it boils away. It's a lot of fun. So thanks for the sub there, Ron. I appreciate it. And man, it's 5 o'clock. Go get some sleep, X Farley. And we're gonna see you next week. Thanks for hanging out. We'll see you next time. Thanks, folks.